Okay, now I want to do a more complicated question. I want to say, suppose that there's unusually good weather in Florida and that increases the harvest of oranges. And what effect is that going to have on the price of apples? And let's assume that the good weather in Florida has nothing to do with the yields for apples. Okay, so that those are independent events, and that the people who produce apples for a living, they don't notice any unusual harvest or yield this year. Okay, so in the book, I broke this up into two separate examples. First, I said what would be the impact in the orange market, and then we're going to use that to see what's going to be the impact in the apple market. Okay, so thinking of the orange market, again, there's really unusually good weather. How would we analyze that using a standard supply and demand framework? So as always with these things, just draw your original generic supply and demand curves and have them intersect. So you've got your original price and original quantity. Now you say, okay, really good weather in Florida that allows farmers to grow more oranges, is that going to affect supply? And this is just the epitome of a supply increase, right? Because now the orange growers just have more oranges on their hands, so at various hypothetical prices, they're going to bring more to market. Other things equal. Okay, so that's the way you would depict that, is a rightward shift in the supply curve. Incidentally, in case you're confused, you might say, well, how come we're shifting left or right? Why don't we shift up and down? Well, just convince yourself of this. A leftward shift of the supply curve is clearly a reduction in supply. But that actually looks like you would be shifting the supply curve upward, just graphically. You know, taking a supply curve and moving it vertically upward is the same thing graphically as if you shifted it to the left. Okay, so in that context, talking about whereas it flips for demand. Okay, so talking about moving curves up or down actually doesn't always give you the right answer, and so that's why it's safer to say a reduction is always a leftward shift and an increase is always a rightward shift when you're talking about supply and demand curves. Okay, but back to our example. So there's really good weather in Florida. Clearly, that's going to increase the supply of oranges. So that you have your S1, and then to the right of that you draw a new supply curve, S2. Is the good weather going to affect the demand for oranges? I mean, you could tell a story and say, oh, because it's a lot warmer, people are outside more and they're getting more exercise, and so they get thirstier, and so they want to drink more orange juice, and so ultimately the demand for oranges is higher, or people go on picnics more and they sometimes bring oranges on picnics, and so the demand for oranges is higher because of the nice weather. You could tell a story like that, but in these kind of examples, if one effect is humongous and the other is kind of small, we usually just say move the curve that's really going to move a lot and don't move the other one. Okay, so that's what's going on here. So I'm just trying to give you an example of, if you did want to say good weather in Florida affects demand, what kind of story would you tell? And I just gave you some examples. But I'm saying in this kind of thing, when you're taking an introductory economics class, if they say there's really good weather in Florida that affects the orange crop, use supply and demand curves to figure out what's going to happen. What they want you to do is to move the supply curve to the right. So that's just a little tip from Uncle Bob there. That's what the professor wants you to do. Okay? So you move that supply curve to the right, you hold the demand curve constant, so what happens? Well, the new equilibrium price is lower and the new equilibrium quantity is higher. So what happened is supply increased, and then we moved along the demand curve. So the quantity demanded increased, but the demand stayed the same. And I'm just, again, stressing that distinction. So yes, consumers ended up buying and eating more oranges, but it wasn't the good weather that made them want to eat more oranges. It was the lower price of oranges that induced them to buy more at the store. Make sure you understand that distinction. If you don't get it, look at your diagrams or whatever and rewind this and watch me say that again. Or in fact, I'll say it again right now, so you don't have to rewind it. Think of it this way. If farmers or orange growers are bringing more oranges to market and the grocery stores are selling them, it has to be true that the consumers, the people who walk around the grocery store with carts and put oranges in their carts, they have to end up buying more oranges also. Right? Those two things have to match up. If the sellers are selling more, well, then the buyers have to be buying more. But what I'm saying in this particular example, what's driving those changes, that increase, on the selling side, what's driving it is the good weather, that causes more oranges to physically be produced. And so now the farmers or the orange growers just have more oranges on their hands, and so they're willing to sell even though the prices are lower. So that's what it means to say the supply curve shifted right. That even at the lower price, the quantity of oranges they're bringing to market and selling is higher than it would have been had the weather not been so great. Okay, now the consumers are also buying more oranges, but why are they doing it? It's not because of the weather directly. The reason they're buying more oranges is that the price of oranges has fallen in this new equilibrium. And so they're buying more oranges because they're cheaper. Because that's what the demand curve shows you. That's what the downward sloping demand curve shows, is holding everything else equal. If oranges get cheaper, people want to buy more oranges. And so that's all we're doing. So that's why we're moving along the demand curve. Okay, so you see how the supply and demand curve framework, it just helps us organize our thoughts. So where the theory comes in, where we might be wrong, is if I say the weather in Florida all of a sudden is really nice, what is that going to do? Well, if I'm just totally wrong about how the weather in agriculture works, I mean, if that means 0 oranges now all of a sudden get produced, well, then my analysis is totally screwed up. Okay, but you see how that works? It's not the supply and demand so much as the way we moved it around. Okay, so just to round out that example, we've argued that the price of oranges is going to fall. So now what can we say about the apple market? Well, we have to introduce a new term. Apples, I'm going to argue, are substitutes for oranges. And what that means is that if the price of oranges goes down, the demand for apples shifts to the left. It goes down. So substitutes, as the name suggests, are things that can often be substituted for each other. And so that's kind of intuitive, where if the price of oranges goes down, people who just want to have fruit are going to buy more oranges and fewer apples. And so if you're thinking about the demand curve for apples, we're saying hold the price of apples constant, people are going to buy less. Okay, so that's why the demand curve for apples shifts left. We're not moving along the apples demand curve. The whole curve itself is shifting because we're saying what happened is the price of oranges went down, and that's going to cause people to buy fewer apples. So think of it this way. For every hypothetical price of apples, the quantity people want to buy is now lower than it was before the hypothetical good weather that caused oranges to get cheaper. Okay, so just make sure you think through that and understand logically what's going on. Why, if you believe me that apples and oranges are substitutes, that the price fall of oranges makes the demand curve itself of apples shift left. But it wouldn't change the supply of apples. And then we said that by construction in this example, assume the good weather in Florida doesn't affect the growing conditions for apples elsewhere in the country. So if you buy that, then the demand for apples shifts left, the supply stays the same, and so in the new equilibrium, the price of apples is lower and the quantity demanded is lower. And that's true in general with these things, that if supply stays the same, demand shifts left, you know the price is going to fall, quantity is going to fall, and some of the other combinations that I've walked you through. Well, that wraps up our discussion. Again, I want to point people to my textbook, Lessons for the Young Economist. You can get the physical book from the Mises Institute, mises.org, or if you just want to browse it before you purchase, just Google Robert Murphy Lessons for the Young Economist PDF. In that lesson, I walk through some further examples, more complicated ones of using supply and demand analysis. And I think, though, that we've done enough for this online lecture. And also, the whole point of this is once you learn the ropes, learn the foundation, then later on in the book, we're going to go through things like minimum wage laws, rent control, even drug prohibition, and we're going to use the supply and demand framework just to illustrate the logic of what I'm claiming in the text. So again, supply and demand by itself is not a theory. It takes no position in terms of government policy or what the effects will be, but it does allow you to very easily illustrate what you're trying to say in words. And so it's important for the economics student to learn how to use supply and demand curves. Thanks, everybody.